start off by complimenting you on your headwear.
Thank you.
What's the inspiration for this?
It's the thing I had at home because the delivery time wasn't quick enough to buy something else.
Great. Okay, well, we're going to get straight into it because we're running a little bit late. Ellen, someone I've known for a few years. I'm really looking forward to this talk today. Toolchains behind Kubernetes development workflows. And I think the sound guys might need to mute. Thank you. Let's start with a canned applause. Take it away, Ellen.
Yeah, let me share my thingy here. Is this working?
Yes.
Okay, so let's get started. I actually didn't realize we were live already. Successful Kubernetes development workflows. This is a talk about, well, let's start with IDEs. So it's a billion years ago. You just learned to program. You're out of school or something, and you're writing, I don't know, Java for a monolith. And what's your tool of choice to help you with all your troubles? It's an IDE. And an IDE does many things for you. Syntax highlighting, code completion, you know the drill. And IDEs came about because there emerged sort of a consensus on what the problem set was for when you're writing code. So everyone had the same issues, like using a debugger and figuring out what those symbols on the screen are, and hence you had syntax highlighting. So there was this problem set that emerged, and an IDE is basically a collection of solutions for those problems. Now, when I started writing code, I first started with Visual Basic 6, I think. And I was never taught to use the IDE features in the thing there. I was just told, here's where you put the buttons, here's where you write the code. So I took that job, my first job, I think I was 13, writing this application for a company. And when I was done, I decided to learn C. And then I didn't have the Visual Basic IDE anymore. And for the next many years, maybe the next 5 years, my IDE was this, notepad.exe. And in Notepad, that's how I learned C. I wrote rootkits in Notepad. I wrote my own WordPress before WordPress was a thing, also in Notepad. And I was very productive at it. Like I didn't need any of the features the IDEs had because, well, I didn't know they existed. So my workflow nowadays is probably very different from most people who use IDEs. For example, when I was writing code for Kubernetes, when I couldn't figure something out, I would just go through all the dependencies, take all the code, stick it all in the same one file, and then I had this one huge 10,000 lines code file, and then things made sense to me because I just learned in this very bizarre way that doesn't make sense for anyone else. But would I recommend that someone starting nowadays not use an IDE? No, never. That makes no sense. It's just, why? So let's talk about Kubernetes. Most of us watching this talk, I assume, learned about Kubernetes kind of in the same way I learned things with Notepad. So most of us probably can write Kubernetes YAML from memory. Most of us probably know everything that is relevant to be known about containers. And lots of us probably are familiar with this kind of crap. And I mean, this is absolutely horrible from a user perspective. Why? But it's there. And that's how we learn. But should we expect that people joining the party right now learn the same way we did? I don't think so. We can provide them with a better way. We can give them the tools to have an easier path than we did. And so Kubernetes and containers are incredible in the technical solutions that they provide, but they give you a less than ideal development workflow. So let's fix that. And here I have a couple messages for you. One is, I'm going to tell you what the problem set is. I'm going to tell you this is what most companies and teams struggle with when using Kubernetes in their development process. I'm going to tell you what the solutions for those are. So you're going to get all of this. But the thing is, right now in this ecosystem, there is still not the I in IDE. Let's say things are not really integrated. So everything is going to be kind of like a build your own adventure book, in the sense that you're going to have to put on your development experience hat and decide for your team, what is it that you want to do? What are the solutions you want to adopt? How do you want to do things? So this is just an interesting GIF from a movie. And my point is, you're going to create the experience that people in your team are going to use to build code. And that's kind of the message I want to convey with this introduction, is that even if you're a team of one, at some point you're going to have to put on your development experience hat and think of what is the workflow of the solutions that you want to use. So why am I talking about this? I'm Al. I work at Tilt. I previously worked at Garden. They're both companies focused on the development experience side of Kubernetes. Half my job is listening to developers complain and then trying to come up with solutions for those. So let me show you what those complaints are and how different teams have addressed them. So the main problem set we're going to address is development clusters. Everyone asks about, oh, what should my dev cluster look like? Managing config files, and that is because we have way too many config files at this point. Feedback loop automation, that means you change a line of code, how long and what is the process for that to be live and running on your dev cluster. And sharing cluster context, it's basically something went wrong, can a friend come here and look at my stuff, and how you do that. And then there's some extras we're going to discuss if there's time at the end. So the protagonists. First is a very large company with 1,200 developers that I can't name because getting their legal department to agree to that was difficult. They have around 200 developers using Tilt. That's the company that I work for. So it's a kind of a significant data set. Next, Uno, they're an electric scooter manufacturer in Berlin, and they are like hipster scooters because they do internet and all of that. So that's why they need a lot of infrastructure, and they have around 25 people. Mindspace is a creative learning and gamification agency in the US. It's very tiny. I think it's just for developers. And we're going to talk about Cluster API. And that is, I think that's SIG Cluster Lifecycle or something. Around 230 contributors on the repo. And what Cluster API does is, well, basically, you use a cluster so that you can create and manage other clusters as if they were Kubernetes primitives. So we have pods and deployments, and with Cluster API, we have machines and deployments of machines, and it works across many different clouds and stuff. So let's talk about the first problem, development clusters. And I'm not going to get into this discussion, but if you're not using a development cluster, you're basically developing a notepad because what you're doing doesn't reflect what you want to be doing. So yeah. Concerns. There are two types of development clusters. There's a local cluster that runs on your laptop and a remote cluster, which is basically a cloud somewhere. Now, when you're using a local cluster, the main things you need to worry about is, one, can your application fit in your RAM? Because if you have 30 gigs of RAM on your computer and your application is larger than that, you're in trouble. And then you need to think about the type of cluster that you want. And let me get rid of this, it's really warm. The type of cluster that you want. So there's Minikube, Kind, MicroK8s. They're kind of equivalent if what you're doing is somewhat superficial. But if you have specific needs, each is a bit different than the other. So you need to be aware of that. And I should probably do a video or an article about their differences at some point. With a local cluster, your bottleneck is going to be how fast your computer is. Network isn't going to be that much of a deal because you're not going to be sending too much stuff up and down the network. With a remote cluster, then the network becomes the main bottleneck because if you're sending images up and down the internet, that's going to potentially have an impact. And the main thing with remote clusters is they cost money. You have to pay every month. So if you're not budgeting for that, you're in trouble. And they require a lot more infra and setup. So you can double-click and install a cluster on your laptop, but you can't double-click and install a Kubernetes cluster on Google Cloud, for example. You're going to need someone who's familiar with that, and that's going to need to be maintained and all of that. But on the other hand, you don't have that limitation. If your app is absolutely huge, that's fine. And yeah, basically, that is the trade-off. So Big company, what did they do? They always run all services. That's their workflow. And there's like 150 of them, so it won't fit a laptop. So their development cluster runs on AWS. They use they separate developers by namespaces, kind of. It's one very large development cluster. This is a question I get a lot. Should every developer get a cluster, or should we do one big cluster for everyone? And I think what I see more commonly is one big cluster for everyone. They don't use managed Kubernetes. They just get the machines and Kubernetize them by themselves. And that's what this huge company does. Now, Mindspace, that's a very tiny company. And what do? Mostly Docker for Mac running on their Macs. They use Docker Compose for testing and blah, 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 because Kubernetes and CI can be fiddly to set up. And there is a point I want to make here, which is Kubernetes on a laptop is fine. Everyone making jokes that, oh, Kubernetes on the laptop is going to set your laptop on fire, blah, blah, blah. No, if the thing you're doing matches that scale, it's fine. Like these people, they are happy using Docker for Mac, and it works just perfectly for them. No problem at all. So, oh, you always need to use a cluster on, cloud, blah, blah, blah. No, you don't. That depends on the level of complexity that you need. So let's please stop shaming people for running Kubernetes locally when it works perfectly fine for them. Of course, there is a problem when there's a point when that causes trouble, and that is, for example, in the case of Uno, they're using Docker for Mac, but their app is too big. It doesn't fit the RAM, basically, and then it starts going crazy. So what happens? They made their application in a way that you have some core services that need to be always running. And then if the developer is working on this, you run these services. If it's running on that, you run those services, and so on. So their application can basically be turned on and off, bits and some parts of it, so that you can still have the convenience of local clusters, but for an app that really should not fit one, but it works fine for them. And Cluster API, it's a bit crazy. So they have this thing where you have bootstrap clusters that then create other clusters. They usually run those with kind. Why are they using kind? Because kind is very easy to tear down and create a new cluster. And because that's what they do, they have to be creating clusters and deleting clusters all day. So kind is perfect for them. The clusters that Cluster API actually creates are usually in managed clouds. So basically all the big clouds out there, you can create stuff there using Cluster API. But the bootstrap cluster that they require usually starts on kind locally. Takeaway from this section: if you're a small company, use a local cluster. It's cheaper, it requires less maintenance, and you can just double-click and install it. If you're a big company and you have people to maintain it, and your application just does not fit your computer anyway, then you use a remote cluster. If you try to mix and match, you're going to get in trouble. So small, local, big, remote, usually. And this is just a funny picture. Now, managing config files. If you're editing Kubernetes YAML by hand, you're using notepad.exe. So let's not do that. Why? Because there's too many config files, and you change a thing in one, you have to update that in all the others. And we're human, and at some point we forget, and then we're in trouble. So we need to automate this. How does big company do with this? They created their own custom-made YAML to YAML generator. Basically, every service has a manifest that says how it works and all the relevant information. You feed that into the generator, it outputs everything that Kubernetes needs. Mindspace, very tiny company. What do? Basically, every service structure looks the same. And then they can basically use the same template and just update some values. And basically, that's the only thing that's different from one service to the other. And they use Helm to do this templating. And then Helm is further automated with Tilt, and we're going to get to Tilt in the next section. Uno does kind of the same thing as Mindspace, but they have some extras, so you can override certain values on your Helm config, which is better for a larger team. Cluster API is, again, the same thing as Mindspace and Uno, but in a larger scope. So everything is extremely uniform in their setup. And then you basically can override some settings and create some user-specific things that overlay on top of defaults and that kind of stuff. Same idea, more complexity, because it's a bigger team with more complex requirements. If you're not familiar with this templating stuff, basically here on one side you have the template, and on the other side you have what the template generates. When you update it on the template, it updates all those fields on the generated stuff. So this is kind of how it works. Takeaway, everyone, literally everyone who's doing this right is using templating. No one's writing Kubernetes YAML by hand. You just tell some system, which may be yours, maybe just Helm, you tell some system how things are supposed to look like, and then it spits out all the machine-readable config file, let's say. And this is very IDE-like, in which things integrate very neatly. So you change a value, a tool like Tilt is going to detect the change, it's going to call Helm, Helm's going to create the new thing, and then we're going to feed that into Kubernetes. Developer doesn't have to be aware of any of this, they just change a value, and things are working automatically. Feedback loop automation, this is where my company comes in, this is what Tilt does. So what is it that I'm talking about? Basically, if you're doing Docker builds to create a new image and Docker push to send that to a registry and kubectl apply to put that in your cluster, if you're doing this every time that you are making changes to your code, you're developing with Notepad. So let's not do updates manually. We have tooling to automate that. The reason is developers like to stay focused. And every command that a developer has to type that distracts them from their code, and every minute that they have to wait for a thing to happen while they're trying to code, that's going to have a large productivity cost, especially since Twitter is just one tab away. So we need to keep developers as focused as possible. And that's why we want to automate this whole process, so that when a developer is coding, they can just code and don't have to worry about any of the boilerplate. So what is this process usually? Most tools in the category can do both of these. So I'm talking about Tilt, but there's also Garden, Scaffold, Draft. There's a bunch of tools out there, Octato, Telepresence, etc. So the normal workflow is that you make a change to your code, and then the tooling picks up that change, it rebuilds the image, ships the image to a registry, updates that inside your Kubernetes cluster. There's also a different workflow where you keep that same container running inside the cluster and just update what's inside the container. So you update your source code files, for example, and restart the application inside the container. And that's much faster. I have a whole talk about this process. You can look at it later. It's called the quest for the fastest deployment time, I think. So basically, this is what I'm talking about in this section. And yeah, on that talk, I basically talk about how to go from a very long feedback loop and full minutes and take it down to 2 seconds. So basically, you make a change to your code, you save a file, blink your eyes, and it's live and running. So how does big company do this? Basically, they use the Tilt stock setup, basically, which is what I just described here. And they have a little neat trick, which is they don't want developers to build images. So they have this thing where developers use images that are already pre-built, and then basically a layer gets added on top with just the code that they're working on and their changes. And then there's a bunch of magic going on in the background, but basically developers, they don't need Docker on their machine, things get built magically. And this is not the typical in-cluster building setup either. It's a lot more magical, but I don't think we have time to go into it right now. So Uno, they want this thing that the big company does, but that's complicated. So at Tilt, we're kind of looking into how to package it up so that everyone can use that, but it's complicated. But the thing that Uno does is that it's extremely impressive how much they automated in their setup. So they inspired the Tilt extensions feature, which is basically ways for you to create automations in your dev workflow and tag them onto your development loop. So as you're writing code, Tilt sees your code changes and does certain things. And then you can create some automations on top of that. And Uno did a really impressive job. So they automated the whole traffic proxy thing, TLS management, vault integration, tracing. You can have sharded clusters, sharded Mongo database inside your development cluster, a bunch of crazy stuff like that. I don't even know how it works, really. Prometheus alerts. They have live reload for Grafana dashboards, which blows my mind. And shout out to David Rubin, who wrote the first third-party Tilt extension and kind of inspired the whole extensions thing in the first place. So yeah, Uno does a ton of automation to make developers' lives easier, and it's really impressive. So Mindspace, they started using Tilt. They were one of the first Tilt users a long time ago because they really wanted production and developments to be both Kubernetes, like both be as equal as possible. They had tons of hacks in the beginning for Tilt, kind of like what Uno does now, and those eventually became native features. So now their setup is pretty much vanilla Tilt, which is cool. And Cluster API. Cluster API, they also have some very complex automation, like a bunch of cert management functionality. They have this thing with the overlays where different users can have different settings and they overlay on top of the defaults, which is really cool. And yeah, so they have a complex system, but it's basically made a lot simpler due to automation. Takeaways. If your services follow a uniform structure, there's a lot of automation that you can do that's going to save you a lot of time. You can recycle a bunch of configs from different things into other things, and that's really cool. And you should basically automate as much as you can. And that starts with like a tool like Tilt, which can be Tilt or can be the other tools that I mentioned before. You automate the basics, and on top of that, depending on your team, you just automate everything so that your developers don't have to worry about doing things by hand. They can just, start the system up and start coding, and they don't have to worry about any, plumbing during the process. Cluster context sharing. This is basically something happened here. Can someone take a look? But the thing that they need to take a look is a Kubernetes cluster. So if your solution for this is copying and pasting logs, you're coding with Notepad. So let's not do this. In the big company, what they do is, because they have one huge shared development cluster, a developer can simply go and use the context of another developer. So if I say, hey, buddy, can you look at my stuff and check if it works? They can just on their own machine log into my cluster, my namespace actually, and see what's up there. And this is really cool, and I think this is the ideal setup, but it only works if you have a very large development cluster, which not everyone wants to be bothered with. A company like Mindspace, basically what they do is, I need to look at your stuff, give me your laptop, and that's it. And to be honest, it works at this scale. Uno is kind of on the same thing, but they make very heavy use of automation, like I mentioned before, so that anything that was complained about more than once, they just automate it out of existence so that you don't need to ask your friend for help, kind of like that. But when you do need to share cluster context, they do it the old-fashioned way. And Cluster API uses another Tilt feature, which is Snapshot. So when you're using Tilt, you can see all of your logs and build logs and all of your services, errors, blah, 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 on the Tilt dashboard. And you can click the Snapshot button, and it basically packages everything up and turns it into a link, and you can just send the link to your friend, and then your friend can open exactly the same thing you're seeing on their screen. And that is a way to share a lot of cluster context. So your friend's not going to be interacting with your cluster, but they're going to see everything that you're seeing in it. So that's really handy. Takeaways. If you have a big shared development cluster, you can just separate things into namespaces and allow one developer to look at what the other developer is doing, and that is ideal. A middle ground is snapshots, and the old-fashioned way is basically, here, look at my laptop, or copy and paste logs around, which I'm not a really big fan of, but at a certain scale, it works and it's less headache. Now, extras. The big company, developers don't interact with Kubernetes directly, basically never. What they do is they have a custom CTL tool, which is a lot simpler than kubectl and made for the needs of those developers. Big company, they have this special version of wrapper around kubectl, and that makes things easier for their developers. So for example, something goes wrong in a pod and you need to debug it. Instead of doing a bunch of kubectl trickery, you have a special command, you set the pod to debug mode, and then you have access to a bunch of tools like netstat, stop, and all of that stuff. But it's kind of wrapped up in a friendlier way so that your developers can have an easier time doing that, and they don't need to be Kubernetes experts. They have a special command that it's like this automated golden path, and you basically type one thing and it sets up the whole 150 services up right away, which is really cool and convenient. And this big company that I'm not allowed to name, interestingly, they have a talk about Tilt at KubeCon, so you can pay attention to that. Now let's talk about debugging. Mindspace has wired up using Tilt to do like the parts fiddly thing. They wired up their IDE to their containers so they can use debugging, which is cool. When you get a much more complex project like Cluster API, they just use printline because wiring up debuggers was going to be too much hassle for them. And the thing is, because the feedback loop is so fast, you basically make a change to your code, save your file, and it's instantly up and running. This is fine. You can just add and remove print lines there, and you save your file, it's already running. So you don't have that compilation cost where you need to wait so long between iterations. That is fast, just use a debugger. So that is interesting. Another takeaway is that setting up debugging and also setting up tracing, which Mindspace and Uno have done, it's very rare. I rarely ever see this done. So maybe there's some opportunity for out-of-the-box automation there. That would be interesting so that more people can use these things. And an area that I still think it's a problem is getting stuff from development to production. Right now, everyone's using that default CI/CD workflow where you like push a commit, it goes to CI, and then blah, 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 and then it goes to CD. There is no magic ship it button. And people are basically, from what I hear from talking to a ton of people, everyone's unhappy about this. So Tilt and Garden have some offerings here. I'm not sure they're ideal just yet. And I think that it's still to emerge what the right pattern is here. So basically, I showed you a bunch of problems that we have solutions for, and this is one where the solution is still not very clear. Going forward, I expect to see more high-level patterns emerge. So, for example, you can download a container image containing all the Go tooling to build your Go binaries inside your Docker image. But you can't just go and download a set of extensions for your development environment to let you, basically, you can download all the Go development stuff for VS Code, but you can't download all the something development extension specifically for working with Kubernetes and containers. So everything that I talked about in this talk, you can't just double click and download a prepackaged solution for all of this. So this is something that I expect will emerge soon. I think things will get more heavily integrated, and this might be good or bad because then you're stuck with one workflow if everything is too heavily integrated. So that's to be seen. And because tools like Tilt, Garden, Scaffold, etc., they are so closely watching what developers are doing, I think there's some statistical riches to be derived from that so that we can understand better what's going on, what's a bottleneck, what isn't, etc. And I think there's some magic to emerge out of that still. We're very early in this. This tooling is very early. It's not completely mature yet, and in a way, I mean, it's good enough for production use, let's say, but I think we can squeeze a lot more good stuff out of it still. Lastly, my message is notepad.exe is not a development environment. So let's not do the equivalent of this for your developers working on Kubernetes. Let's give them proper tooling and proper automation so they can be productive. That's what I had to share with you. Thanks for watching. Here's how you can get in touch. And if you want to check out those companies, here's links for them, except for the one that I cannot talk about.
All right.
Yay, applause.
There we go, the applause. Ellen, thank you so much. I know we're a little rushed there, and I could see that you were really motoring through the slides, but really interesting stuff. Thanks for letting us know how we can learn more. I'm not sure if you're planning to stick around for a little while.
Yeah, I'll be in the chat. So.
Great. So if you want to ask any questions to Ellen, go and find her through Trello. And
also, feel free to ping me on Twitter and that kind of stuff.
There we go. So you've now got many ways to follow up with Ellen to ask some questions about this very interesting talk. Next, we're going into an hour-long gaming competition. I think we're probably the only software conference I've ever been to that has a gaming competition. You can go and find that in the fun track. As I said, you can catch up with Ellen either on Twitter or through the chat. And I look forward to seeing you all in the fun track shortly. Thank you, Ellen.
Thank you.